Hey, darlings. This is lesson 15, I think, for you guys, right? Let's write that down because I try to keep track. Notes for video lesson 15. Okay, so we left off last on, let's see, we went over fundamental theorem of calculus. I went over, I think, all the homework problems, right? And I left you with a review sheet to struggle through, 16 questions. I said, I kind of went through it in the beginning of video lesson 14 and went question by question and just said kind of like hints, you know, what you should do, what they're asking you to do. My hope was that in looking at this homework, you were able to do some of these or half of these or maybe most of them, wherever you're sitting, to see how comfortable you were with it, but try it. And this entire lesson is going to be that I'm going over each and every single one of these. So I hope it helps. Just to touch base on a couple of things. First of all, I want to say thank you and shout out to some of you. I've gotten some really, really nice text messages lately. You guys thanking me for what I'm doing, making these videos and just in general. And it has come at a time that I can't thank you enough for making me smile. I am personally stressed out just doing all of this. And the baby's coming soon and having a baby in the middle of all this, and I was kind of hoping it was going to get much better or be better before I had a little one coming into the world. So thank you. I want to thank those of you who have reached out to me personally and made this old lady smile. I really, really appreciate it. But I want to thank you guys because I'd have to say 85 to 90% of you are working your butts off. You're trying, you're in contact with me, you're doing work. And you're really, really, you know, putting forth the effort. And I can't thank you enough because I'm sitting here at 11 o'clock at night at the Sakara crib and starting to record videos. And I'll probably be doing this till about 12:30, 1 o'clock in the morning tonight. And then tomorrow, it'll take me about 10, 12 hours to edit and upload them to YouTube, believe it or not, just to post it for you guys for Wednesday. So you guys working hard and you guys doing your part is what motivates me to keep going on my end. So I thank you in return. I also noticed some of you are texting me with like, hope you have a great spring, hope you have a great summer. And I think I said to Jimmy, I'm like, I don't know why they're saying goodbye to me, like school isn't over. But I think some of you are thinking I'm having the baby soon. It's soon, but not yet. And kind of on the fence as to what's going on. So tentatively speaking, I'm not sure. Going to see a doctor tomorrow. I have a sonogram the next day. My C-section's still scheduled for June 15th, so I'm still on track, but that could change after they see the sonogram because then they see how big she is and things like that. As things change, I will update you as I would if I was in a classroom. Okay, I'm hoping that if I do go out on maternity leave the last 2 weeks, that Miss Teish, my student teacher that you guys loved, supposedly, would step in for the 2 weeks and take over. And basically those last 2 weeks, guys, I don't plan on doing much new instruction as much as I just plan on doing something. We're not doing finals. So whether it's review or, I don't know, something. I was talking to my husband about it. I want to be a little creative. So basically I would set up the lessons even if Miss Teish was facilitating it through Canvas. The other idea I've had is to continue working those last 2 weeks since I'll be home anyway, and start my maternity leave in September, just to try and keep some consistency for you guys. I've spoken to my husband about it. He's in full support of it, but I feel that you guys have had a tremendous curveball thrown to you this year with school shutting down in the middle of March and just all of this, that to have to change and have a teacher for 2 friggin' weeks, the last 2 weeks nonetheless. I don't want to have to do that to you guys. So I'm going to try my best. I've reached out to the district and to my union about possibly working the first 2 weeks that I have the baby and have the C-section. I know, I'm crazy, right? But if I can keep some consistency for you guys, I think it would be best for everybody right now, especially the seniors, my senior classes. I really want to try and be there to the end for you guys as much as possible so there isn't any problems with grades or anything like that. Okay, so that's just personal stuff I'm sharing with you. I will keep you posted. I don't have definitive answers. I'm not saying that's definite. I'm waiting to hear back to see if that's allowed, if I can do that. Okay. All right, so let's get this party started so I'm not on here for the next 40 minutes talking about calculus at 11 o'clock at night. And if you hear something really strange right now, that gross sound, hear that? That is my pit bull devouring her food at 11 o'clock at night. She just gave me a dirty look, by the way, because she hears me talking trash. I'm sorry, you're beautiful, but you eat like a beast. Okay, so anyway, all right, let's take a look. Number one, antiderivative. So remember, antiderivative or integral, what do I want you to think of? Area under the curve, very good. So when there are no numbers on the integral, you have to remember that at the end, what do you write? Plus C, very good. And I think I reminded you that in the last video as well. So for the first two problems, we have to remember to do that, okay? So we're just doing straight derivatives here. So add 1, put it over the number. X to the 5th over 5. Minus, add 1, put it over that number. X to the 4th over 4. Plus, add 1, put it over that number. And then at the end, you have to put a plus C. There's nothing to simplify here. Nothing to reduce. Nothing to put in lowest terms. So that's your answer. Wham, bam, thank you, ma'am. Now, this is the oops. CYA, you got to be careful here. Let's simplify first. Always, always, always simplify first if you can. So if it's squared, that means how many times am I multiplying it? That's right, ladies and gents, I'm doing it twice. So I would have x to the 4th. A negative 2x squared and negative 2x squared would be a negative 4x squared if I combine my like terms, right? It's these. You guys okay with that I skipped a step? Negative 2x squared is negative 4x squared, and then negative 2 times negative 2 is positive 4 dx. All right, and then from here we proceed like we did with number 1. Add 1. So this is what I get for doing calculus at 11 o'clock at night. Add 1, put it over that number. Add 1. Oh my God, Roxy, are you seriously that thirsty? So first you have to hear her inhaling her food, and now you hear her doing this. And then she'll probably do like a really gross, weird burp afterwards, so get ready. Plus, whenever you see a constant, stick an X with it. And then at the end, there's no numbers to plug in, so we have to remember to write plus C. Are we all good in the hood, my darlings? Wham, bam, thank you, ma'am. Okay, 2 down, 14 more to go. All right, this one, I was ghetto. I think I explained in the last video, and I hand wrote multiple choices in because I struggled so much with my software at home, and I don't have my test generator. I thought I grabbed the case that the CD should be in. I think the CD's stuck in my computer at school, which I'm really pissed about. I hope it's there in September, or God, oh my God, there when I get back. That thing was expensive. I spent like, I'm not even gonna lie, I think I spent like $400 buying that test generator. But anyway, so I had to piece together things, and I converted multiple choice questions to short answer, and in the process of doing that, wiped out these multiple choices and then realized, oh my God, this has to be multiple choice, blah, blah, blah. Long story short, I had so many problems putting these computers together and merging PDF documents and everything else technologically, you know, that I just decided I was going to handwrite it and you guys could deal with it. Okay, so general thing with this problem is antiderivative or integral. Think area under the curve. Very good. So it's the area between the curve and the x-axis. Now remember, when you have, we started this way back when, a couple of weeks ago when we started definite integrals. The stuff above, it kind of goes hand in hand with top minus bottom. The stuff above the x-axis minus the stuff below. Why? Because we think of the stuff below as negative land. Okay? So it says A, B, C, and D are the areas of the shaded regions between the graphs of function f and the x-axis as shown below, which is basically what I just explained to you. The value of, if you integrate from A to B of this entire function. So they want to know how you would figure out the integral from A to B. Well, you have to do the stuff above, who's above, A and D, minus who's below, B and C. So which choice would you choose? The stuff above, A plus D, minus the stuff below. Okay, so that has to be choice A. Are we all good in the hood, my friends? Alrighty, moving on. Up, number 4 is a game changer. Now we have numbers to plug in. So it's similar to number 2. And what do we have to do first? Starts with an S, ends with a Y, sounds like simplify. So we're going to simplify first. So we have I'm going to guess my husband's watching that Michael Jordan special. No, it's just funny. Is that what you're watching? I can tell by the really corny 90s music. He's been obsessing with Michael Jordan lately. Okay, so we're going to simplify first and then integrate. So 3 times 3 is 9. We'd have a negative 3x, and a negative 3x is a negative 6x. And then negative x times negative x is x squared, positive. And I don't know, that just makes me be like, meh. So I'm going to just rewrite it in standard form because, I don't know, things like that just annoy me. And I feel like it annoys some of you too. All right, so there we go. Let's integrate. Add 1, put it over that number. X cubed over 3 minus 6 squared over 2 plus 9x from negative 1 to 1. Now, I'm going to reduce this. X cubed over 3. And negative 6 divided by 2 is negative 3x squared plus 9x. And we're plugging in from negative 1 to positive 1. So we ready to roll? Let's do it. Plug in who first? Top minus bottom. So I'm going to plug in the 1 first. So 1 cubed is 1. So we have 1/3. And then 1 squared is 1. 1 times negative 3 is negative 3. 1 times 9 is 9. You guys okay with that? So first I start out plugging in the top guy, everywhere I see x. Minus. Now I'm going to plug in the negative 1, everywhere I see x. So negative 1 cubed is negative 1, so it becomes negative 1/3. Negative 1 squared is positive 1, that stays negative 3. Negative 1 times 9 is negative 9. Okay, I need some common denominators here, yeah? All right, let's do it. So we're going to have 1/3. And I need to make these all over 3. So that's negative 9/3, right? Negative 9 divided by 3 is negative 3. And I'm going to make this 27/3. Because that would give me 9. And then over here, I'm going to do it similar. I have my negative 1/3, my negative 9/3, because that's negative 3, and my negative 27/3, because that would give me negative 9. All right, so let's do this. 1 minus 9 is negative 8. And negative 8 plus 27 is 19. 19/3. And then over here, and again, I put a remind out saying that you can get a free 6-month trial of TI Texas Instrument graphing calculator, this thing. They give you a free 6-month trial. You can download it on a device, even an iPad. So you could use a calculator at this point. I would use a calculator. At this point, I would use a calculator. All right, so we have 19/3 and then minus, let's do this. Negative 1 and negative 9 is negative 10. Negative 10 minus 27 is negative 37/3. How are we doing so far? Minus a negative will always be a positive. Okay, so that's 56/3. And I do not think that reduces. Right? Let me check that real quick. Nope. It does not. All right, so that's the answer, 56/3. How are we doing, my darlings? All right, let's keep going. All right, number 5. Yes, number 5. You guys, I feel like usually like these. I don't know how much you're liking them because we're not in class and I can't communicate with you. But they're the properties, okay? So given, you're going from 0 to 3 of the function and you get negative 3. So this is what I do. I draw myself a little x-axis. And I say, okay, from 0 to 3 is negative 3. The Last Dance is presented by so it's below the x-axis somehow, some way. Or it's more below the x-axis. From 0 to 6, it's 5. This whole space is 5. Find from 3 to 6. So they want to know what's this. The whole thing's 5, and this part's negative 3. So what would I do to figure out what's left? The whole thing's 5, and this part's negative 3. So what am I going to do with these two to figure out this part that's left over. That's right, I'm going to subtract it. So what do you get? What's 5 minus negative 3? It's positive 8. Are we okay with that part? And I feel like the visual helps a little bit. Just think of this as your x-axis. All right, what are these? Derivative and antiderivative. We just finished talking about this. What's this? That's the FTC, the fundamental theorem of calculus, the second part of it. The first part is just integrating. Add 1, put it over that number. Add 1, put it over that number, and area under the curve. The second part of it is derivatives and antiderivatives are what of each other? They're inverses of each other. So they do what? Cancel each other out. So if I have the derivative and the antiderivative and these cancel, then you got to check yourself before you wreck yourself. What do you do with this guy up top? First of all, you want to make sure who's up top. That's right, the variable. Is it x? Yes, it is. So now if it's just x to the first, which it is, I straight plug it in everywhere I see the variable. So the answer to this is sine pi halves x. And you're done. Nothing else to do there. All right, 7's a little wiggity whack, but let's look at it. I know the derivative and the antiderivative are going to cancel, but WTF? What do I do with this? Because I know the x has to go on top, but now they're both x's, so what do I have to do with them? That's right, I have to split them up. And you do the top guy minus the bottom guy when you split it up. So that's how I know who to write first. I'm going to start out up here, x squared. So I'm going to go from 0 to x squared, so the variable's up top. I'm going to take the derivative of the antiderivative of this, of cosine squared t dt. And then I'm going to do minus, see that? Now do the bottom guy, 0 to 2x. Do the derivative of the antiderivative of that same function. Are we all okay, my darlings? So now there's a second part of this. Now I have the variables up top. I split it up so that it's from a number to a variable, and I can actually do the rule now. And the trick says when you take the derivative of the antiderivative, what do they do to each other? They cancel each other out. And then I take this guy and I just plug it in. But, and it's a big but, it's no longer just x to the first. So this is the chain rule. Now I have to be careful. So after I plug it in, so I have cosine, that's terrible C, squared x squared, I have to multiply by the derivative of this out in front. So what's the derivative of x squared? 2x. Minus, I start out plugging it in, cosine squared 2x, and then you multiply by the derivative of this guy out in front. What's the derivative of 2x? It's just 2. Okay, my darlings? All right. All right, that's number 7. All right, and here's another one. Similar but not as intense. Derivative and antiderivative, what do they do to each other? That's right, they cancel each other out. And then I take this guy, let's make sure. Rule number 1, the x has to be where? On top. Is it on top? Yes, it is. So now I just want to plug it in. But the second big but, it's a big but, is it x to the first power? No, it's not. So I have to start out plugging it in. Now this is t squared. So it becomes x cubed squared. And then I got to take care of the fact that it's not x to the first power by multiplying by its derivative out in front. What's the derivative of x cubed? That's right, 3x squared. So now one more step. I'm just going to simplify this part. Cosine x cubed squared, you multiply that, x to the 6th. Remember, when it's power to a power, you multiply like the distributive property over parentheses. All right, guys, are we all good with that one? All right, I think I gave you a few extra ones. The derivative and the antiderivative, what do they do with each other? That's right, they cancel out. Is the x up top? Yes, it is. Is it x to the first? No, it's not. So I start out plugging it in, but then my last step is I have to multiply by its derivative. What's the derivative of x cubed? We just did this. Remember with derivatives, it's the opposite of integrals, so you multiply and take one away. That's right, it's 3x squared. So now let's simplify this. I have 3x squared over x cubed. Can I go any further? I have 2 x's up top and 3 on the bottom, so I'm left with how many x's? I'm left with an x, and where is it left? It's left on the bottom. That is the actual answer I would want. All right, and the last weird rule with these, with the fundamental theorem of calculus. The derivative and the antiderivative, what do they do with each other? They cancel out. Uh-oh. What's the problem here? Where's the x? It's in the bottom. We don't like that. We need it where? Up top. So what do? I'm going to rewrite it the way I need it to be. But once I do that, now that I change the order, I have to pull out a what out in front? A negative. So just be careful of that. So derivative and antiderivative cancel. Now the x is where I need it. It's up top. Is it x to the first? Yes, it is. Yes, it is. Yes, it is. So it's easy like Sunday morning. I'm going to plug it in everywhere I see the variable. So it becomes x cos x, but don't forget who's out in front because I switched the order. The negative. How we doing, loves? Hanging in there? Am I going too fast? I'm asking you like you're going to tell me, and I'm going to actually slow down. But you know what? You could just hit pause. All right, so anyway. Find the average value. Keyword, average value. Okay, the average value formula is 1 over b minus a, and you integrate from a to b of the function. So, here's my a, here's my b. What up, b? Sorry, guys. Massively thirsty. Jimmy made, we call it chef rice in this house, but fried rice. Homemade with like the whole shenanigans in it. And it's so salty, that stuff, but I love it. All right, so anyway, but I am parched. Okay, so what up, b? So my a is 0, my b is 3. So if I plug it into the formula, it's 3 minus 0, and I'm integrating from 0 to 3. You always want the bigger number up top, and this is the function. Okay, so let's rock and roll. 3 minus 0 is just 3, and then let's integrate. If it's a constant, what do I stick with it when I take the antiderivative? That's right, a variable, 9x. Then I add 1, put it over that number, and then I'm going to plug in from 0 to 3. The very last thing I do is multiply by a third. Okay, so we ready? Who do I plug in first here? The guy up top, the 3. 9 times 3 is 27. 3 cubed is 27 thirds, which is just 9, right? And then on this end, minus. If I plug in a 0, I just get 0. Yep. So what is 27 minus 9? I believe that's 18. Now I got to multiply these, so I'm going to reduce it first. 3 goes into itself once, goes into 18 6 times. So the answer is just 6. But again, if you have the calculator, you can do it easy like Sunday morning. All right, you ready? Whoa, Nelly. Whoa, Nelly. Okay, yes. So these are a little out of order. On the quiz or the graded assignment that I'm posting for the homework for this, it's going to be in order. Like all these guys are going to be in the beginning, okay? But I had to type these, and I had to type them with Libre, which is a software that we use here in the house on our laptop. Excuse me. We don't do Microsoft Word. And yeah, I had a massively hard time doing this. I think I complained about it last time. It put these question marks in. Just ignore that. I got it to go away on this one, and I couldn't get it to go away there. All right, so remember, we're back to no numbers on the integral. So I'm still going to start with what always first if you can. Starts with an S, ends with a Y, sounds like simplify. So if I can, I simplify first. Then you integrate. Add 1, put it over that number. If there's no numbers to plug in, what do I write at the end? Plus C. Very good. Okay, so I can simplify here, right? Everybody can be divided by an x squared. So when you divide, you subtract the exponents. So I have 2 x to the fourth, right? 6 minus 2 is 4, plus 3x squared. 4 minus 2 is 2, minus anything divided by itself is just 1. Is everybody okay with what I just did there? All right, let's add 1, put it over that number. So I have 2x to the 5th over 5, plus 3x cubed over 3, minus, what do I stick with this 1? An x. And then plus, don't forget your plus c. So this becomes 2x to the 5th over 5. What happens with the 3's? They cancel. And yes, you have to do that, or you're going to lose a point. Are we all good in the hood, my darlings? Okay, just a few more. Oh, so first thing I'm going to do here is I'm going to take care of this part. So I am going to simplify a little bit. Instead of 1 over t squared, I'm going to bring this up and make the exponent negative so I can actually add 1 and put it over that number. Okay, now let's integrate. Add 1, put it over that number. So it's negative 2 plus 1. That's right, it's negative 1. And then you put it over that number. The negative 3 stays, and up we have trig here. So let's get triggy with it. Remember what I said. Do your derivatives, go forwards, because that's how you train your brain. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tan is secant squared. And the derivative of secant is secant tan. Now this is my crib sheet. You always write it. The minute you see trig, write it down. Don't force your brain to go backwards in your head. You will make a mistake. So I'm looking over here for cosine. Up, there it is. Now, there's a problem with this though. The antiderivative of positive cosine is positive sine. So what's the antiderivative of negative cosine going to be? That's right, negative sine. So we keep the negative, and it's sine t. And don't forget to write your plus c. Now one more time. The antiderivative of positive cosine is positive sine. So the antiderivative of negative cosine is going to be negative sine. All right, let's clean this up because I don't like negative things in my life. I'm a happy-go-lucky type of girl. So this negative 1, if I want to make it positive, I kick its butt back where? Back to the bottom. So it becomes t to the positive 1. But I'm left with this negative up top, right? Is everybody okay with that? And I have minus 3 sine t plus c. Okay, another one with trig. We're going to get triggy with it. Na 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 na. Na 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 na. Getting triggy with it. 3 secant squared theta. Oh my god. Oh my god. Oh, look at all this. Oh, FML. We have to plug in. All right, so you ready? We don't drop the 3. We bring it for the ride. Now, the secant squared. Good thing I already wrote this. Who's the antiderivative of secant squared? It is tangent. Tangent theta. And I'm plugging in from 0 to pi thirds. Now, pi thirds is how many degrees? How do I figure that out? That's right. It is 60 degrees. I figured that out because it's 180 divided by 3. Okay, so I'm going to plug in this top guy minus plugging in the bottom guy. So 3 times, and I'm going to do tan 60 minus 3 times 0. 3 tan 0. Okay, so how do I get these? All right, the 60 is the 30, 45, 60 chart. Sine, cos, tan. The first 2 are all over 2. Sine's the first one, so you start with the square root of 1. Then it's square root of 2, square root of 3. Reverse alphabetical order, so you reverse it. Rad 3, rad 2, rad 1 is just 1. Tan's the third one, so it starts out over 3, and then you steal the rad 3 from the one above it. Now think to yourself, what's 3 divided by 3? It's just 1. But it's not 3 divided by 3. It's a rad 3. So to answer your question, what's tan of 60 degrees? Rad 3. So we have 3 rad 3s. And then I need to know tan of 0. Now tan of 0 comes from the unit circle. This is the 0.10. Do you guys remember how you figure out tan? Tan is slope, right? Change in y over change in x. So it's y over x. So what's 0 over 1? It's just 0. So the answer is just 3 rad 3s. Are we all okay with that one? Because that's a little crazy. Okay, 2 more, guys. 2 more, which really is like 4 more because there's 3 parts to the next one, but whatever. All right, so I gave you a table. All right, here's my X's and here's my Y's. And I'm sorry that I didn't have this nice little table drawn in. In all honesty, I'm still trying to figure out how to use this program that I use at home. And it had the table part sketched in on what I was looking at, but when it printed invisible. All right, so they want 6 equal subintervals from 2 to 14. And they want a trapezoidal. So the trapezoidal is, you have 2 different ways you can do it. You can do that h over 2, and then it's the first y plus the last y plus 2 times all the middle y's. Or you could do LRAM plus RRAM divided by 2. Okay? I'm going to show you both just because it's review, and I want to make sure that depending on which one you're comfortable with, you know how to do it. Okay, so 2 to 14, they want 6 equal intervals. So let's see if that works. 1, 2, 3, 4, 5, 6. And they're all 2 apart, so they're equal. So that works. We can use this chart exactly the way it is. So the h over 2, your h. Your h is 14 minus 2 divided by that 6 equal intervals. So 12 over 6 is just what? That's right, it's 2. That's the h part. Now the formula is h over 2, which means 2 over 2 is just what? 1. So when I plug it into the trapezoidal, it's just a 1 outside. Now it's the first y plus the last y, and 2 times all these guys in the middle. Oh my God, I'm doing the X's and I need to do the Y's. Oh, Sakaro, you suck. This is why I hate writing in pen. And this is why I usually write in pencil. However, when I'm doing these videos, the pencil doesn't show up good. So 1 times the first y, 2.38, plus 2 times all the middle y's. My bad, guys. Wouldn't be Sakaro if I wasn't making mistakes, right? So I'm going to say the formula again. The first y plus the last y and 2 times all the guys in the middle. This is the h over 2, which ended up just being 1. H is how you do LRAM and RRAM. It's just 14 minus 2. That's from this. Divided by the 6 equal intervals. That's your n. So that came out to 2. And then when you plug into the h over 2, if h is 2, 2 over 2 is just 1. Now, if I put that all in the calculator, you get 16.87. Now, you could do it this way, or you could do LRAM plus RRAM divided by 2. Now, LRAM. How far apart is each x? It's all 2. And then add all the y's except the last guy. That's your LRAM. Add all of them except for the last one. For the LRAM, I got 18.08. Okay. RRAM. Still 2 apart, each of the x's, that doesn't change. Add all the y's except for the first y. So I cut out the 2.38. And I include the last y on this one. And I got something like 15.66. So the trapezoidal is this guy plus this guy divided by 2, which gives you the same answer, 16.87. All right, how are we doing, darlings? All right, one more. Just for fun. All right, let's do it. 16. I want the area under the curve. That means find the integral of this function from 0 to 3 with 6 equal subintervals. So this is kind of like finding the h first. That's how you start with LRAM and RRAM. I got to find the h. So I do 3 minus 0, and I divide by my n. Okay, one more time. 3 minus 0, and then I divide by my equal subintervals, n. So 3 over 6 is a half, which means when I set up my x and y axis now for LRAM and RRAM, I'm going to go by halves from 0 to 3. So 0, a half, 1, 1.5, 2, 2.5, and 3. That's where the halves come in, count by halves. Then I'm going to plug this all into the calculator, into the original function. Now, if you have the graphing calculator and you sign up for the free subscription, the easy way to do that is you put the function in, x squared plus 4x. You go to table set, second window. I'm going to start with 0, and I'm going to count in 0.5s. Now go to table, second graph, and there's your table that you want to copy from 0 to 3. Okay, a little bit of a trick. Otherwise, you just proceed as usual. Take your x's, plug in whenever you see x to get your y. So for 0.5, it'd be 0.5 squared plus 4 times 0.5, and you get 2.25. This one's 5, 8.25, 12, 16.25, and 21. Now, we just reviewed LRAM and RRAM before. First of all, how far apart is each x, each base of the rectangle? That was the h, right? It's a half. Add all of them except for the last one. So 0 plus 2.25 plus 5 plus 8.25 plus 12 plus 16.25. Put it all together, and I got something like 21.875. Let me put that in the calculator. Are we okay, darlings? RRAM. The half stays the same. You're using the same x and y values. Now I'm going to add all of them except for the first y. So I start with 2.25. And I do not include, and this time I include the 21. So this gives me 32.375, I believe. Now, MRAM I feel like is the one that you guys have trouble with. MRAM is the midpoint of each of these x's. Midpoint is you add them up and divide by 2. And that's how you get a quarter. If I add up a half and 1, I get 1.5. 1.5 divided by 2 is 0.75. Does everybody see what I'm saying? So I have 0.25, 0.75. Keep going. 1 and 1.5 is 2.5. Half of $2.50 is $1.25. Okay. Halfway between 1.5 and 2 is 1.75. Halfway between 2 and 250 is 225. Halfway between 250 and 3 is 275. It's the midpoint. Now I take each of these x's and plug them in, or I go to my table set, second window, start at 0. No, I'm going to start at 0.25. And how does it change? This is important because I have to do this anyway. It's still going 0.5 apart because it's 0.25, 0.75. Now if I go to the table, there it is. So 1.0625, 3.5625, 6.5625, 10.063, 14.063, and 18.563. Is everybody okay with that? Now again, if you don't have the calculator, you're not comfortable doing the table, you just take each x, plug it into the function of ACX, and that's how you get your y value. So for the first one, I would do 0.25 squared plus 4 times 0.25. Now, how far apart is each x value? 25 cents and 75 cents is what's the difference? It's still 50 cents, it's still a half. And this one I add all the y's. Now, if I put that in, I got something like 26.93825. Now, you could have just rounded to 3 or 4 decimal places, but I left it. All right, ladies and gents, here we are. Saved by the Bell. That is question 16. And hopefully you feel good about that. All right? You have it there. Text me questions, whatever. If you have it, I'll try to help you out the best I can, as I always do. And be well, my friends. Take care. Brush your goddamn hair.